As you can see on the myofibrils, there's this tube that looks kind of like a netting. There's like a whitish kind of tube that covers this myofibril. There's a whitish one here. There's one over here. And then there's like a grayish one that kind of covers the rest of the myofibrils. So what we're going to do is we're going to use the green to color in the white tubing that covers these myofibrils here. Except, notice how it goes underneath the sarcolemma. I'm not going to color that just because I don't want it to be too messy. So I'm just going to color in this whitish tube right here. These are called your transverse tubules. They're called transverse because they run perpendicular with the myofibril itself. So transverse means you go perpendicular with the myofibrils. And that's about all I'm going to color so it doesn't get too messy. It does continue underneath the sarcolemma here, but we'll just leave that alone. So underneath the image, I'm going to label this as number 5. So number 5, these are your transverse tubules. Can you please say transverse tubules? Transverse tubules. They are empty vessels, kind of like arteries or veins, except they're not for blood. So these are channels for molecules to travel through. Put it on my desk. Thank you. So in order for molecules to get into the transverse tubules, there has to be an opening to the outside of the cell because the molecules have to get in through the outside of the cell. So we're going to draw some openings or circles here on the sarcolemma to show that there are openings so that things can get into or out of the cell. Because remember, cell membranes are porous. They have holes. I just threw in a few holes there. So I'm just going to add that. They open up to the outside of the cell membrane. What's the other word for a cell membrane? Sarcolemma. Sarcolemma. Now there's another set of netting or tubing here. It's like a darker kind of gray. It's right next to the transverse tubule. And notice this one has branches that comes off of it and covers all of the myofibril. So what I was gonna do is I was gonna use blue here to fill in the tube that runs right next to the transverse tubule. It's gonna have some branches, so I'm gonna draw some branches off of it. Yeah, me neither. I'm just drawing blue lines, to be honest. Yeah, I can only see some of them. I was making up the rest of it. So some of them I can see pretty well and for sure trace those ones, but otherwise just fill it in. Just make sure it covers up the myofibrils. So these are for ions to travel through, and without ions, the myofibrils can't contract. And so you want to make sure the myofibrils are covered with all of these tubes. So I'm going to label that as number 6. Number 6 is called the sarcolemma. endoplasmic reticulum. Can you please say sarcoplasmic reticulum? Sarcoplasmic reticulum. Sound familiar? Endoplasmic reticulum. So it's actually the same like an endoplasmic reticulum, but it's specialized in a muscle cell. Kind of like how cell membrane is called sarcolemma, endoplasmic reticulum is called sarcoplasmic reticulum. So it's an empty channel way that regulates, and I said ions earlier. Specifically, it's calcium ions. So if you haven't taken chemistry, I need you to write channel that regulates calcium ions. Okay. So basically, in order for your sarcolemmas to contract or to get shorter so that you can move, you need calcium. That calcium is going to travel through from the outside of the cell, through the sarcoplasmic reticulum, to the muscle or the myofibrils, okay? But let's say you're running for a good amount of time. There's calcium floating around in the SR at first, but once you use up all that calcium, where does your body get more calcium from? Your bones. So osteoclasts will start breaking down the bones, sending more calcium that way through the bloodstream, enters in through the sarcoplasmic reticulum, and then it gets spread out throughout the myofibrils. Okay. Somebody asked, well, is it possible for you to completely run out of calcium? If you have no calcium, then what does that mean? You're probably dead. Your bones are completely tapped out. No more calcium. You're not intaking anymore, and that's why you're not moving, most likely. Maybe. There's probably other things going on, too. All right. So we have a couple of other quick labels. I'm going to go back to black or pencil here. Some of you might have noticed in the drawing, there are these kind of like dark gray bean-looking things. Somebody in another period said it looks like a slug.
Oh, yeah.
Sure. Leech, whatever. I don't know. There's a couple. There's one here, 2, 3, and a fourth one that gets cut off. What are they? Ah, good guesses. These one are nuclei. So I'm going to add a 7 for all of them, or for some of them. The mitochondria is in this picture, but it's really hard to see it. If you look very closely, there was a line that was pointing right there. And you remember in bio when you drew the mitochondria, the inside had like the squiggly folded membrane? That's what it's trying to show, but it's really hard to see. Yeah, there's another one at the bottom too. Yeah, it's like, where's Waldo? Okay. They're there. We're not going to label them today just because it's kind of hard to see for some people. So we're going to add 7. Oh my gosh, nuclei. And then number 8 is going to be that outermost layer of the cell. Again, what do we call the cell membrane? I'll use sarco words. All right, number 8 is the outer wrapping there. So number 8 is the sarcolemma. Can you please say sarcolemma? It is also known as the cell membrane. It has openings to the outside, so things can go in, things can go out. All right, and then